Hi folks, I have a new reaction for you today, which is the substitution reaction. In a substitution reaction, one functional group or atom is replaced with another to form a new compound. In this case, I have an example of an alkane undergoing a substitution reaction. Now, a regular alkane will not have any specific functional groups. It will only have hydrogens sticking out from the carbon atoms. And therefore, when we add a halogen to it, it will replace one of the hydrogens in the alkane with the halogen and forming a haloalkane, and also result in a byproduct called hydrogen halide. So the halogen will attach to the hydrogen of one of the parts of the alkane and become a hydrogen halide. A general formula or general example here in a general equation is RH plus X2, X2 representing the halogen here. This is our halogen, and this would be our alkane here. And so alkane plus halogen will form our haloalkane. In other words, the halogen has attached to the alkane, and we have hydrogen attached now to the halide. Another example, and we can look at a chemical compound here. Let's say we have CH3, CH2, CH3, and I am picking a 3-carbon compound, a propane, on purpose so that I can show you the different variation of compounds you can produce by substitution in this scenario. So we are adding X2, let's say we are adding Br2, and this is happening in the presence of light as a source of energy. Regular temperature 25 degrees Celsius can happen at room temperature, and this will result in CH. The bromine could go on the first carbon. In that case, it will become CH2, CH2, CH3. So that's one of the isomers you can make. Also, instead of replacing the hydrogen on the first carbon, it might replace the instead of replacing the hydrogen on the first carbon, it might replace the hydrogen on the second carbon, in which case you will get a different compound, different isomer, which would be BRH and CH3. And in both cases, the other product that will be produced is HBr, the hydrogen halide. So we have two different isomers being produced in this case. And when we look at the next lesson on Markovnikov's rule, we will see which one would be the major isomer and which one would be the minor isomer. In other words, which one would be formed in greater quantities when this reaction progresses, when propane reacts with bromine to form bromoalkane. So we have two different isomers of bromoalkane and hydrogen bromide. I hope you enjoyed this lesson. If you liked it, please hit like, subscribe, and I hope to see you again in the next lesson.